Good morning, students. So today we are starting with the lab preparation of haloalkanes. So let's do the lab preparation of haloalkanes. Lab preparation of haloalkanes. We'll be doing the preparation of haloalkanes or alkylhalide from the following compounds. We'll be doing from the compounds called alkanes. We'll be doing from the compounds like alkenes. We'll convert alcohols, ROH, into alkyl halide. Then we'll discuss two named reactions, namely Finkelstein reaction, which is used for the preparation of iodides only. And then we are going to discuss the reaction called Schwarz reaction, which is used for the preparation of only fluorides. You will find I'll be making fluoride by only Schwarz reaction. So today we are doing the preparation, the lab preparation of the haloalkanes, and we are doing from 5 compounds. Number 1 alkanes, number 2 alkenes, number 3 alcohols, the Finkelstein reaction which is used to make the fluorides, Finkelstein reaction which is used to make iodide, and the Schwarz reaction which is used to make the fluorides. So one by one we are going to prepare them or convert them into alkyl halides. So let's see how do we convert all these compounds into the alkyl halide. First of all, let's start from the compound called haloene. From alkenes. Let's see how do we convert alkanes into alkyl halides. So we are starting from the compounds called alkenes. From alkanes, we are going to prepare alkyl halide by simply using free radical substitution reaction. Which is called as nothing but halogenation. We'll be doing halogenation of alkanes to convert them into nothing but alkyl halide. It is an example of free radical substitution reaction. In this reaction, if you see the reactivity of the halogens, reactivity means the rate at which they react. The most reactive halogen we have is fluorine, followed by chlorine, followed by bromine, followed by iodine. That's the order of reactivity. In fact, with fluorine, the reaction is so fast and such exothermic reaction. With fluorine, the reaction leads to explosion. Though generally we avoid fluorine in this particular reaction, or we have to use it in the diluted form. Now, in alkanes, we can have 3 different types of carbon atom, namely primary, secondary, or the tertiary. The hydrogens which are present on the primary carbon, they are called as primary hydrogens. The one which are present on the secondary carbon is called as secondary hydrogen. The one which is present on the tertiary carbon, they are called as the tertiary hydrogen. So it has been found that the order of substitution is in this order. It's very easy for us to replace a tertiary hydrogen, followed by secondary hydrogen, followed by primary hydrogen. We can replace tertiary hydrogen very quickly, then secondary hydrogen, and then primary hydrogen. The reason behind this is the stability of the free radical. We know from 11th class, tertiary free radical is more stable than the secondary and then the primary. Now for the substitution reaction, the conditions that we use for the substitution reaction is either we use UV light, or if you're working under dark condition, without light, you can heat it. So either we can use UV light, or if you're working without light, you can heat it. That leads to the substitution reaction. Now let us see the example. Suppose we have our methane. We reacted with 1 mole of chlorine in the presence of sunlight, H mu. What is going to happen if you react it with 1 mole? One of the hydrogen is replaced by the Cl. What we get is CH3Cl, chloromethane. Now since chloromethane has got 3 hydrogen, you can react it with 1 moles of chlorine in the presence of sunlight. 1 more H will get replaced and you will get dichloromethane. Since it has got 2 hydrogens, you can react further. React with 1 more mole of chlorine in the presence of sunlight. You're going to get the formation of a compound CHCl3. That's called chloroform, trichloromethane. You react it with 1 more chlorine. So one by one, all the hydrogens can be substituted. And finally, you get carbon tetrachloride. Now the reaction will stop because there is no hydrogen which is present, which can be now replaced by the halogen. So in this case, what we do is alkane we react it with halogen in the presence of sunlight, or under dark condition we heat it. The hydrogen atoms can be subsequently replaced by the halogen. Hydrogen removed or substituted by the halogen. Now let us see some more examples. Let's see this thing that tertiary hydrogen can be replaced more readily than secondary hydrogen, followed by the primary hydrogen. Now let us take the example of ethane and let's use another halogen, let's say bromine. So we have got ethane, CH3, single bond CH3. Ethane has got 2 carbon. Both of them are primary. So the hydrogens are primary hydrogen. We react with bromine. Let's say we are working under dark condition. We heat it. If you're reacting with 1 mole of bromine, any of the H will be replaced by Br. And you will get the formation of bromoethane. You will get the formation of bromoethane. Plus, of course, the byproduct will be HBr. Now let us take another example like propane we take. We reacted with chlorine, again in the presence of sunlight. Now propane has got 2 types of carbon. This carbon is a primary one, the middle one is a secondary one. This is again a primary carbon. So these hydrogens are primary, these are nothing but secondary. So in this case, we will not get 1 product, we can get 2 products. Either this hydrogen or this hydrogen may be substituted. So if you replace this hydrogen, you will get product 1 chloropropane. We get 1 chloropropane. And if the middle hydrogen gets substituted, you get nothing but the formation of 2 chloropropane. We'll get the formation of 2 chloropropane. These are not going to be formed in equal amount, unequal amount. One will be larger amount, one will be smaller amount, one will be major, one will be minor. We know secondary hydrogen can be replaced more readily than primary. So this one will be the major product. And this one will be nothing but the minor product. Now there's an NCERT question which is given. The NCERT question says that propane, if you want to get a di-substituted product, how many different products can be formed? We want di-substituted product, means we have to want to replace 2 hydrogens with the halogen simultaneously. We reacted with 2 moles. So propane, if you react with 2 moles of chlorine, what are the possible products? Now what will happen? 2 hydrogens will be replaced by 2 Cl. We get a di-substituted product. What can happen? One possibility is that both the hydrogens are replaced from this carbon. So we get a compound of this type. Both the Cl present at the first carbon. The hydrogen from the first carbon replaced by the 2 Cl. Other possibility is that both the hydrogen from the second carbon gets replaced by Cl. So di-substituted product or dichlorinated product possible is this one. That is 2,2-dichloropropane. What is the third possibility? We can replace this hydrogen and this hydrogen by the chlorine. So we can get this product. These are the possible di-substituted product that we can get with. And what is the last possibility? We can replace this H and this H and we can get this type of product. So if you subject propane to dichlorination, you want to get a dichlorinated product, di-substitute product. These are the 4 products which are possible. 1, 2, 3, 4. So that is your di-substitution. So it's a very simple reaction. Alkane, you react with halogen in the presence of sunlight. Sunlight is missing. You can work under dark condition, you can heat it, and the hydrogens will be replaced by none other than halogen. Which halogen reacts the fastest? That is fluorine, then chlorine, then bromine, then iodine. Which hydrogen is substituted more readily? It is tertiary, followed by secondary, followed by primary. Now let us see the reaction with a halogen called iodine. There is a problem. You've done 11th class methane. If you react with 1 mole of chlorine, the reaction is reversible. You are supposed to use sunlight. H will be replaced by I. You get iodomethane plus the byproduct HI. Now why the reaction is reversible? Reaction is reversible because HI which is formed is a reducing agent. What HI will do, as soon as this reaction takes place, this is going to reduce this product back to methane. It is a reducing agent. It will reduce iodomethane back to methane. But we don't want the reverse reaction. We want a good yield. So if you want a good yield by reacting with iodine, what you should do is that methane, you react with iodine. In the presence of sunlight, you should also use an oxidizing agent, nitric acid. If we use an oxidizing agent, nitric acid, what is going to happen is one of the H will be replaced by I, and the HI, which is the byproduct which is formed, that will be immediately oxidized by nitric acid into I2, H2O plus NO2. HNO3 is going to remove HI, preventing the backward reaction. The reaction will become irreversible, and the yield of the reaction is very, very high. So whenever you react alkane with iodine, do use a nitric acid, which is an oxidizing agent, which will help in removing the HI, preventing the backward reaction. Yield of the reaction is going to be very, very high. So in all these reactions, basically what we are doing is that we are replacing hydrogen with the halogen. And what are the conditions we are working? Either we use sunlight. If you are working without sunlight, then we have to use the heat as a source of energy to break the bonds. Now let's discuss some of the NCERT question based on this concept. The first question of NCERT goes like this, that we have got a compound with the formula C5H12. That's pentane. They have asked us to draw the 3 isomers for pentane. Draw 3 isomers of pentane, structural isomers for pentane, which you even do in your 10th class. Then they have asked us that suppose you are subjecting pentane to monochlorination. What is monochlorination? Reacting with chlorine one time. Suppose you are going to do monochlorination of isomer. You have to identify that isomer which on monochlorination is going to give you 3 products. Which isomer is going to give you on monochlorination 3 product. What is monochlorination? Reacting with chlorine one time. What would be dichlorination? Reacting with chlorine 2 times. Then we have to identify that isomer which is going to give you 4 products, 4 possible products. And then we have to identify that isomer which is going to give you only 1 product. So first of all, let's draw the 3 isomers for the pentane. The 3 isomers possible are as follows. We can have normal pentane, 1, 2, 3, 4, 5. We can have isopentane, that is 2-methylbutane. And we can have neopentane, which is 2,2-dimethylpropane. These are the 3 isomers possible for pentane. Now you can see if you react this isomer with chlorine one time, you can get the formation of 3 products. 1, 2, 3, 4, 5. You react with chlorine one time in the presence of sunlight, you can get 3 possible products. What are the 3 possibilities? We can replace hydrogen from here, or from here. You can get the formation of 1-chloropentane. We can get the formation of 2-chloropentane. We can get the formation of 3-chloropentane. 3-chloropentane. So normal pentane will be the one which gives you 3 product. That is going to give you on monochlorination 3 product. The answer of the first part is it has to be normal pentane. Now let us see the isomer which on chlorination can give you 4 products. Second one, the answer would be nothing but isopentane. Let us see why isopentane can give 4 products, 4 monochlorinated product. Suppose we have got the isopentane. Let us see when you reacted with chlorine one time, where the position where chlorine can attach. The chlorine may attach on this carbon, on this carbon, on this carbon, and either of the two carbon you can put Cl. So one possible product is this one. We can put the Cl at the first carbon by replacing hydrogen. On the second carbon, this will be the product. On this carbon, this will be the third possible product. And the fourth possible product can be, you can put Cl on either of these carbon. These are both primary carbon, they're equivalent. So let's put Cl over here. So in the case of isopentane, when you react with chlorine one time, you can get 4 possible products. So the second answer is the isomer has to be nothing but your isopentane. Now let's see which isomer will give you only one product. Naturally, only one is left, that is neopentane. But why on earth neopentane on reacting with chlorine is going to give you only one product? The reason being, if you see the structure of the neopentane, it has got 5 carbon. The middle one is a quaternary one, doesn't have a hydrogen. All other carbon atoms are primary. This is primary, this is primary, this is primary, this is primary. All carbon atoms are equivalent. The hydrogens they will have will also be primary. So if you reacted with chlorine one time in the presence of sunlight, you can put Cl at any carbon you like. They are all equivalent. They are all equivalent. They are similar. They are all primary. So suppose we put Cl over here. What will be the IUPAC name of this compound? 1-chloro-2,2-dimethyl propane. Even if you put over here, the IUPAC name will come out to be same. Even if you put it over here, then IUPAC name will come out to be same. Even if you put Cl over here, the IUPAC name will come out to be same. So since all the 4 carbon atoms are equivalent, on monochlorination you will get only one product. So please remember, monochlorination means reacting with chlorine one time. Dichlorination means reacting with chlorine 2 times. Di-substitute product, mono-substitute product, we can have tri-substitute product or tri-chlorinated product and so on. So this is the first type of question which can come from this type of thing. Many of you would have done this question even in the class 11, because basically this halogenation of alkane is you have done also in class 11th. Now let's do one more question. The question says like this: a compound has a formula C5H10. It says the compound does not decolorize the brown color of bromine water, does not decolorize brown color of bromine water, which you know is a test for unsaturated. Since it is not decolorizing brown color of bromine water, means it is not an alkene, but the formula shows it is an alkene, but the test doesn't come out to be true. It is written that it on monochlorination, reacting with chlorine one time in presence of UV light, gives only one product. In presence of UV light gives only one product, suggesting all the 5 carbon atoms in this compound are equivalent. They are of same type. C5H10 actually corresponds to the general formula CnH2n, which is a general formula of an alkene. But it clearly specifies in the question that it doesn't decolorize the brown color bromine water. So that means it is not an alkene. Now we should know that CnH2n is also the general formula for cycloalkane. So this may be a cycloalkane. Now since on chlorination it is giving only one product, means it has got 5 carbon which are all same. Either all of them are primary, either all of them are secondary, or either all of them are tertiary. So 5 carbon we can make a ring, that is cyclopentane. Cyclopentane, there are 5 carbon and all of them are similar. They are all secondary type. All of them are attached to carbon. So all the hydrogens this compound has got is 2 degree hydrogen. So when you reacted with chlorine in the presence of sunlight, you can put Cl at any position and you will get only one product, that is 1-chloro-pentane. So the compound has a formula C5H10 is cyclopentane. So this is the first method of preparation of alkyl halides they are done from alkane. It was simple halogenation reaction, which I told you was nothing but a free radical substitution reaction. The substitution reaction happens in the presence of a UV light. If you're working without light, you can, under dark condition, you're going to heat it. Then only the substitution takes place. Which halogen reacts the fastest? It is fluorine, then chlorine, then bromine, then iodine. Which hydrogen is replaced faster? It is tertiary hydrogen followed by secondary followed by primary. If they ask you to make mono halo derivative, means you react with halogen one time. If they ask you to draw dihalo derivative, means having two halogens, you can react with halogen two times. In today's class, we are also going to see the preparation of alkyl halide starting from alkenes. We are going to convert also alkenes into alkyl halide for today's class. This we can do simply by addition reaction with HX. Addition reaction, we can use HX. HX we can use as HCl, we can use HBr, we can use HI. You do know when addition reaction happens of alkene with HX, we can have two products, two possible products. Either we can go for the product in accordance to the Markovnikov's rule. The Markovnikov product we can have. Now you have done the Markovnikov rule in your 11th class. Hope you would have forgot. Just to revise, Markovnikov rule in a very simple version says hydrogen will attach to the carbon with already more number of hydrogen, with already more number of hydrogen. Simple rule, rich becomes richer. You're going to put hydrogen to that carbon which already has more number of hydrogen, and halogen is going to attach to the carbon with less number of hydrogen. You can even go for, if the need arises, you can go for anti-Markovnikov product. You know, anti-Markovnikov rule was discovered by the scientist with the name of Kharash. You also know anti-Markovnikov rule is valid under only one case, when you're adding HBr, and that too when organic peroxide is present. If any of the one thing out of the two things is missing, you can't use anti-Markovnikov rule. You should have HBr, no HCl, no HI, and you should have organic peroxide. Then only the reverse of Markovnikov rule will take place. Reverse means now hydrogen will attach to that carbon which has got less number of hydrogen. So let us see with 2 or 3 examples how we can convert alkene into alkyl halide by simply doing addition reaction with HX. That is halo acid. It can be hydrochloric acid, it can be hydrobromic acid, it can be hydroiodic acid or HI. So let us see first of all the formation of Markovnikov product. Let us see the formation of Markovnikov product. First of all, we are going to form Markovnikov product. What is Markovnikov rule? Again to revise, rich becomes richer with respect to hydrogen. Hydrogen is going to attach to the carbon which already has more number of hydrogen. So suppose they ask you to convert propene into 2-bromopropane. Propene into 2-bromopropane. Let us write on the structure. Propene, all of us know, 3 carbon with a double bond. What is 2-bromopropane? It's 3 carbon with the Br at the second position, 2-bromopropane. We have to attach H over here, Br over here. We have to attach H to the carbon with more number of hydrogens. Simply add up HBr. H will add over here, Br will add over here, and double bond will become single bond. Simple Markovnikov addition. You suppose you have to convert propane to 2-chloropropane, add up HCl. If you want to convert propane to 2-iodopropane, add up HI. Depending upon what halogen you have to add, you can use that particular HX. Now this is one of the NCERT questions. Few people find it to be tough, but it is not tough. 2-methylpropene. It is one of the NCERT conversion given at the back. 2-methylpropene to 2-methylpropane. Let's draw the structure, then it will be more clear. Propene with the methyl group at the second position. We want to get this thing. We want to get 2-chloro-2-methylpropane. We want to put Cl at the second position. So simply add HCl. H will add over here, Cl will add over here, Markovnikov addition, and you will get 2-chloro-2-methylpropane. So if you want to place hydrogen to that carbon which has got more number of hydrogen, you have to use Markovnikov rule, and you can use HCl, HBr, HI depending upon what halogen you have to attach. Now when I say that the hydrogen has to attach to the carbon with more number of hydrogen, few people think that in propene the H is going to add on this carbon because this has got the highest number of hydrogen atoms. But you know hydrogen cannot add up over here. Addition reaction happens on the carbon with the double bond. You can't expect an addition reaction across the single bond. It has to be across the double bond. So you have to compare this carbon and this carbon. Now let us see the anti-Markovnikov product also. Anti-Markovnikov product is valid when you are adding only HBr. You can make only bromine containing compound, and that too in the presence of organic peroxide. It's valid only for the halogen bromine. If you want to get a bromine containing compound, then only you can go for your anti-Markovnikov rule. Anti-Markovnikov rule. After the name of the person who has discovered it, it is also called as Kharashev. We know that. So suppose somebody asks us to convert propene into 1-bromopropane. They ask us to convert propene into 1-bromopropane. We have to put halogen at the first position. Naturally, it is an anti-Markovnikov rule. So what we can do, we write propene, we want to add HBr, and since we are looking for anti-Markovnikov halogen on the first carbon, we have to also use organic peroxide. The Br will attach on the first carbon, the one having more number of hydrogen, and you will get the product 1-bromopropane. But over here, instead of HBr, if you use HCl and HI, anti-Markovnikov product will not be formed. Is valid only for HBr, and that too in the presence of organic peroxide. If organic peroxide is missing, if you add HBr, it will give you the Markovnikov product. So anti-Markovnikov rule, if you want to use both the two things simultaneously. Even if one is absent, you can't go for the formation of anti-Markovnikov product. Now just for the sake of practice, you can convert butene to 1-bromopropane. Same thing, add up HBr, organic peroxide. Butene will be converted to 1-bromobutane. So in today's class, we have done the preparation of haloalkanes starting from two compounds. Number one, from alkanes by simple halogenation, which is a free radical substitution reaction. In that, the conditions were sunlight or dark heat. You can use the halogens like chlorine, bromine or iodine, depending upon what halogens you need to substitute. And from alkene, we can do addition reaction. And the alkene addition reaction we have done just now, this particular reaction, this one, the Markovnikov product, basically it is an electrophilic addition reaction. You do know anti-Markovnikov rule when we use H peroxide. It doesn't follow that electrophilic mechanism. It is a free radical addition reaction. All this we have discussed in class 11th. The other three preparation from alcohol, then the two name reaction, Finkelstein and Schwarz reaction, we are going to do in tomorrow's class. By that time, please prepare the notes, go through this topic very carefully, listen all the words very, very carefully, and please stay at home, do exercise, study hard, take care. Thank you. Have a nice day.